Welcome to Daily Physics. This series of videos are going to share with you more about visible light and its applications. As the scope of this presentation is very large, we break down the syllabus by parts, for the ease of your learning. The learning objectives of our scope of presentation include visible light and its properties, behavior of light on various surfaces, reflection, and mirror image. Let's first look at some of the properties of light. Light is energy, in the form of electromagnetic waves. Visible light has a wavelength between 400 to 700 nanometers. Light travels in a straight line. Light travels at an incredible speed of 3 times 10 to the power of 8 meters per second. Light rays may reflect or refract when they strike a surface. Speed of light changes as it enters a different medium, for example air to water. What happens when a beam of light strikes a surface? Two natural phenomena occur. One is reflection and the other is refraction. We will first cover reflection in this video and look out for our other videos on refraction. Let's explore more about reflection. When a ray of light strikes the surface of a smooth object, it is reflected. This ray of light is termed the incident ray, and the angle formed by the incident ray and the imaginary line, known as the normal, is termed the incident angle. In regular reflections, the incident angle is equals to the angle of reflection. A clear and sharp image is formed when regular reflection takes place. When light rays fall on rough surfaces, as the surfaces are irregular, the light rays may strike the surface at different angle, causing different angle of reflection. Hence, images formed are blurred, in this case. Let's see more examples of reflection. When a beam of white light is shown on transparent object, such as a glass prism, it is dispersed into its composition of colored lights. This happens due to refraction, the bending of light rays, as they enter a different glass medium from air. Some of the light rays are also reflected from the prism, enabling us to see it. We see colored objects because their respective color light is reflected from its surface. For example, we see a red object because only red light is reflected from the surface of the object, and all other color light are being absorbed. We can see the blue car because only the blue light is reflected, and all other colored light are being absorbed. Hence, we see the car as blue. Let's explore other aspects of reflection. Mirror images. In a mirror diagram, the mirror is represented with a straight line and a series of slanted lines on one side of the mirror. The object is usually placed on the side without the slant lines. The object distance denotes how far the object is placed from the mirror. The object size denotes the height of the object. An identical image will be formed on the opposite end of the mirror. The image formed in the mirror is virtual, as it cannot be casted onto a screen. The object size is equals to the image size in a regular mirror. The object distance is equals to the image distance. The images are laterally inverted, as when the left hand is raised by the object, it is reflected as the right hand in the mirror image. How is the image being seen by an observer? Let's explore a simple example together. When we place an object in front of a mirror, the light rays reflected from the object will strike the mirror, forming a reflection. Tracing the light rays from the mirror, we can locate the point of intersection between the two rays and see the object in the specific location of the mirror. What happens if we have objects that are transparent? We shall explore more on the bending of light in our next video on refraction. We hope you like our presentation. If you have a physics question, feel free to email us at millennialearninghub@gmail.com or simply scan the QR code and type in your question in the form. We will respond to you soon.